Hello, and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video, we'll be looking at checkpoint 5.21, coming from section 5.6. This is our ratio and root tests. It says to use a ratio test to determine if this particular series converges. The series is the sum, as n goes from 1 to infinity, of n cubed divided by 3 to the nth power. Now the ratio test tells us to take the limit as n goes off to infinity of the ratio a sub n plus 1 divided by a sub n, and we want to take the absolute value of that. Now whatever we get for that limit, we can match up with any one of these three conditions. If that limit goes between 0 and 1, then it converges absolutely. If it's bigger than 1, then it's going to diverge, and if it's equal to 1, then the test does not provide any information, and you will have to use another test like a comparison test or something else. Okay, so let's do the ratio test for this, and the ratio test tells us to take our n plus first term, a sub n. By the way, if it's not clear, it's going to be n cubed over 3 to the n. So the n plus first term, a sub n plus 1, will be the term where n gets replaced with n plus 1. So that's n plus 1 to the third power and 3 raised to the n plus 1 power. And when we have these fractions and you're doing the ratio test, this is going to be your limit. They call it rho here, which is the Greek letter for r. We're going to take the limit as n goes off to infinity of n plus 1 to the third divided by 3 to the n plus 1 power, and that whole thing is divided by n to the third divided by 3 to the nth power. This is a 3, this is an n, and we want the absolute value of that. Whenever we do these ratio tests, because we're taking ratios of fractions, we're going to end up multiplying by reciprocals. So we have an n plus 1 to the third divided by 3 to the n plus 1 times 3 to the n divided by n to the third. And because these are all positive anyways, I'm going to drop the absolute value. And then I will also note that this 3 to the n plus 1 is actually equal to 3 times 3 to the n. That will allow us to cancel the 1 of the 3 to the n's, and then all we have left is 3. And then meanwhile, the n plus 1 to the third and the n to the third can go into one fraction. That would be the fraction n plus 1 divided by n, all that to the third power. So we have the limit as n goes off to infinity, and a 1/3 coming from this 3, and then we have an n plus 1 over n, all raised to the third power. Now if we take the limit of this, this 3 can come all the way out, and then we take the limit as n goes off to infinity of n plus 1 over n to the third. There's limit loss that says we actually can take the limit as n approaches infinity of n plus 1 over n and then raise that to the third power. And then if we put the 1/3 up, then you can say that that's equal to that. And if we take L'Hopital's rule here, this is just going to be 1, and then we have 1 to the third power, and that's also going to equal to 1. And so the whole thing will be equal to 1, except for the 1/3 that you have out in front. Then your result is 1/3. So your rho is equal to 1/3. That's your limit. And if we go look at the conditions again, it satisfies this first condition. Rho is less than 1. Therefore, the series absolutely converges. So we'll say this is less than 1. And then therefore the series that we're looking at, this is n cubed divided by 3 to the nth power, as n goes from 1 to infinity, also converges. Okay, this is your result, and I hope that helps. Oh, sorry. absolutely converges. All right, good. I hope that helps. Good luck.